Hey guys, it's great to be back with you all today. We're going to be reviewing at least the first half of the released STAAR test that we took the other day. And let's get ready and look at some of these questions. Look at question number 1 first. You follow along as I read. It says, which list shows the numbers in order from greatest to least value? Okay, so we're going to box in right here where it says greatest to least, because we're going to start. We want the first one to be the largest and the last one to be the least. So, and whenever we're comparing numbers, we always want to look at the largest place value first. So let's look at answer choice A. So in answer choice A, I have the first number has a 3 in the 10,000s place, and all the other digits, or all the other numbers, don't have anything in the 10,000s place. So this is definitely the largest number, so I'll put a 1 right there. And we'll look at the next number. And if we look at the next number, we're going to look at the thousands place, and they both have a 9 in the thousands place. So we'll go to the hundreds place. Okay, this number has a 0 in the hundreds place, and this one has a 1 in the hundreds place. So that makes this the next largest number, and this is the smallest number. So that is not correct. Okay, we'll look at answer choice B now. Okay, if we're looking at answer choice B, we're going to look at the 10,000s place first, and the second number has a 2 in the 10,000s place. This one has a 3 in the 10,000s place, and this doesn't have anything in the 10,000s place. So that makes this the smallest right here. So I can automatically eliminate that one. And as a matter of fact, it looks like it's going from smallest to largest. So this is the second, and this is the largest. So this is not correct either. It is going from least to greatest, but we're looking from greatest to least. So we're looking at answer choice C. And we're going to look at the largest place value, which is the 10,000s place. This has a 5 in the 10,000s, and this has 5 in the 10,000s, and this doesn't have anything in the 10,000s or thousands place. So next thing we'll look at is the thousands place. This has an 8 in the thousands place, and this has a 0 in the thousands place. So this is automatically the largest. And I go ahead and say this is the second largest because my 581 doesn't have anything in the thousands place. So that automatically makes this the second largest, and this is the smallest. So this one looks like it may be correct. We'll go ahead and look at the last one. And on the last one, it looks like the largest place value is the 10,000s place. And the other two numbers don't have anything in 10,000s place. So that makes this the largest. I might automatically see this is going to be the second largest, and this is the smallest. But that is not correct. So C would be our correct answer choice.
Hello, and welcome to 5-Minute Math. Today we are looking at the third grade concept of multi-step multiplication and division problems. This is standard 3.4K in the great state of Texas. And we are looking at the second problem of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, and then unpause it. We will look at our answers together. So Gerardo's going to buy some gum, 3 packages of mint, 2 packages of bubble gum, and then each package had 8. So this is definitely going to be one where we probably want to draw a picture. So what I'm going to do is I'm just going to draw 3 packages of mint. So I'm just going to put M, M, M. So I got my 3 packages of mint here, and then 2 packages of bubble gum. So I'm just going to put B and B. They don't have to necessarily be the same size, but I went ahead and drew them all to be the same size because it says that each package had 8 pieces of gum. So I've got my 3 packages of mint, my 2 packages of bubble gum, that each is going to give us a clue that we're most likely dealing with multiplication or division. Whenever we see each, that gives us a clue that we're most likely dealing with equal groups, and that's what multiplication and division looks like, is equal groups. So if each package has 8, well, let's just put 8 right here. And we actually have a few different ways we can do this equation here. So one way to do it would be just to add up all of the 8s, right? And we can just say, well, we've got 5 groups of 8. 8, 16, 24, 32, 40. Now we went ahead and actually did something in our head if we went ahead and said 5, because it's really not 5. What it is it's 3 packages of mint plus the 2 packages of bubblegum. So we added those two together, and then we multiplied them by 8 each. So we did a 2-step problem. We might have even done that first step in our head. So we multiplied our 5, but that came from 3 plus 2. That's going to equal 40. Another way we could look at it would be, let's just add up our mint separately and our bubblegum separately. So if we say our mint has got 3 packages of 8, so I'm going to say 3 times 8. And let's see, that's going to make 24. And then we're going to add that to our 2 packages of 8, because we've got 2 packages of this bubblegum here. And I'll say 2 times 8, that's going to make 16. And so if we wanted to do that, 24 plus 16, that is once again going to equal 40. So anyway, we look at it, our answer here is going to be 40. Now, how do we get some of these incorrect answers? Well, these incorrect answers are actually quite interesting. We get them if we're doing something with all these numbers, we're just doing the wrong thing. So this 26 would be, I've got 3 packages of mint gum and there's 8 each. So if you're getting 26, most likely you're thinking, all right, 3 times 8, that equals 24. And then you know you've got this 2 left. And you're like, what do I do with this 2? Well, let's just add the 2. And if you add the 2, guess what you're going to get? 26. But that doesn't make sense to add the 2 because those 2 packages are actually 8 each. You would need to add the 16 to get up to 40. So that's how we got that incorrect answer. This next one also looks at this 8 and 3. So we're going to start with H, starts with 8 times 3. It says, all right, so I've got 24 pieces of mint gum, but I need to do something with this 2 again. Rather than adding 2, what if I just divide by 2? And so if we divide by 2, well, then our answer is going to get 12, which is going to get this, but that doesn't make any sense. We're not dividing by the packages of bubblegum. We're going to add those 16 pieces of bubblegum, 2 packages of 8. So that's how we get that. And then this last one says, well, I've got 3 and 2. So 3 times 2, that means I've got 6. And then if we multiply that by 8, we're going to get 48. So what this one did is this just took all 3 numbers and multiplied 2 times 3 times 8 to get 48. But as we know, that doesn't make any sense. Our answer is G.
Okay, we'll go to like problem number 3. It says, Alberto ran for exercise every day for 16 days. The table shows how many days he ran each distance. So this row right here is the distance that he ran, and the hash marks are how many days he did that for. So what we're trying to figure out is which dot plot represents these data. Okay, so first thing I'm going to look at will be how many times he ran a mile. And right here on our number lines, they have the distances on the number lines, and there's the dots to represent how many days he ran that far for. So on day for the 1 mile, he did it 2 days. There's 2 hash marks. So if we look at answer choice A, that works. Answer choice B, that works. Answer choice C, that works. Answer choice D only shows 1 dot for 1 mile, and he actually did 2. So I can eliminate answer choice D. We don't need to look at answer choice D anymore. So we'll go ahead and look at how many days he ran 1.5 miles. It looks like he probably ran 1.5 miles most days. And it looks like he did it for 5 days. So I'm going to look halfway between 1 and 2 would be 1.5. And answer choice A says 1, 2, 3, 4, 5. That works out. Answer choice B says 1, 2, 3, 4. So I can eliminate answer choice B because it said he ran 1.5 miles 4 days. And answer choice C has 1, 2, 3, 4. So I can eliminate that one too. So it looks like we're down to just A, but I'm still going to go check the rest of the data and make sure it matches. So for 2 miles, he looks like he did it for 3 days, and I got 1, 2, 3. That works. For 2.5, looks like he did it for 4 days. That's right here. That's 1, 2, 3, 4. And for 3 miles, looks like you did that 2 days. 1, 2. So our correct answer would be answer choice A.
2019 STAAR test number 4. So if you haven't already, go ahead and take a moment, pause the video, see if you can answer this problem, then unpause it and we will look at the correct answer together. All right, so we need to find the expanded form, and we have 90,000 plus 200 plus 40 plus 1. So we have the expanded form. What we need is the standard form. And so remember that the expanded form is when you have the number showing as a sum of each value. So we've got 90,000, and then 200, and then 40, and then plus 1. So if we really wanted to, an old-fashioned way, kind of a long way to do this, but this is an addition problem. So if we've really wanted to, one of the slow ways would be just to line this up. Now, it is kind of messy, and you have to make sure you write everything correctly. Because if anything gets squished, if your zeros are too skinny, and if you don't put anything in a line, well, then you're going to have problems. But if you can keep everything in a line, well, these problems are pretty easy because you can just treat them as an addition problem. So we've got 1, that's 4, that's 2, 0, and that's a 9. So the answer is 90,241. But that's the long way. Let's see if there's a shorter way to solve this problem. So one thing that we need to do is we need to realize that we're dealing with place value here, and we don't really need any of these zeros. We just need the place values. And so what I'm going to see is I'm going to find the largest value, and in this case it's this one right here. There's 5 digits, so I'm just going to draw 1, 2, 3, 4, 5. And what I'm going to do is I'm going to just count over spaces, and I'm going to put the digit in the correct spot. So if I start from this 90,000 here, start from the right, if I count over 1, 2, 3, 4, 5, well, if I could start over from my places here and count over 1, 2, 3, 4, 5, that's where that 9 goes. So that one's done. If I start at the 0 here and count over 1, 2, 3, 3 spots over is the 2. So 1, 2, 3 spots over is the 2. 1, 2 spots over is the 4. And then in the very first spot is that 1. And so what we have here is almost a number. We have a blank. That's the trick in this problem. So we're going to put a 0. And the reason we need to put a comma here is because we are changing periods. Sometimes we'll call them periods, sometimes we'll call them families. But the ones family or the ones period are the first 3 digits put together, the ones, tens, hundreds. And then this second period or the second family are the 1,000s. This 9 is in the 10,000s. That's why it's worth 90,000. So that's why we have that comma there, because you do groups of 3. And then you put a comma. Let's look at the incorrect answers and see why they got them incorrect. So this 9 right here, and this is H, so we'll go and mark that here. Let's line up our F, and we'll see what the problem is. We see 9,241. The 241, obviously, that's correct. Here's our issues. We got confused with this 9. This 9 right here is 9,000 because it's in the 1,000 spot, but it's not 9,000, it's 90,000. So it's missing a whole magnitude of 10. So that's why that's wrong, because this one should be right there. G is 92,041. So at least the 9's in the correct spot. But as you can tell, my issue here is going to be this 2. This 2 is in the 1,000 spot, but really it belongs in the 100 spot, because if this 2 is in the 1,000 spot, this would be 2,000, but it's actually 200. And then finally J. J just kind of switched the 4 and the 2. If you look at those two right there, they switched the 4 and the 2. It should be a 2 and a 4. And that's how we solve this problem.
Okay, problem number 5. It says Serafina put a total of 42 cupcakes into packages. She put 6 cupcakes into each package. What is the total number of packages Serafina used for the cupcakes? So I'm going to circle my important information on this one. Important that she did 42 cupcakes. And right here, it looks like she put 6 cupcakes into each package. Next thing I'll do, and that looks like all the information I need to solve the problem. Next thing I'll do is I'll underline the question. It says, what is the total number of packages Serafina used for these cupcakes? I'm going to box in some operational clues. I see the word total right here. See the word each right here. And it looks like I'm trying to find out numbers of packages. I'm trying to figure out how many packages she used. So I'm going to do some evaluating right now. When I'm evaluating this, this sounds like we have some equal size groups because I'm talking about each right here, and I'm putting cupcakes into packages. So whenever I'm talking about equal size groups, I always like to use a get strategy. So I got groups, each, and total. And on this one right here, it looks like I'm trying to figure out how many packages there are. And I believe the packages are going to be my groups. So that's what I'm trying to find out. I can see right here it says 6 cupcakes in each. So my each is going to be 6. And right over here it says total of 42. So whenever I'm trying to figure out, whenever I'm talking about equal size groups and I know what the total is, it sounds like it's going to be a division problem. So the division problem I'm going to solve is 42 divided by 6. And the multiplication problem I could use to help solve this would be something times 6 equals 42. And I know my multiplication factor pretty well. 7 times 6 equals 42. So I think it's going to be 7 packages. Okay, but if you're not really good at your multiplication facts yet, I would do an array for this. If I'm trying to figure out how many groups there are, I can't do the grouping strategy, so the next best thing would be do an array. So I would do my array, and I'm going to make some blue cupcakes, because I like blue cupcakes. And I'll just start putting cupcakes into rows, and I'll put 6 in each row because there's 6 in each package, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, and 42. So when I do it like that, I can see I've got 1 package, 2 packages, 3, 4, 5, 6, 7 packages, or that's 1 package, 2, 3, 4, 5, 6, and 7 groups or 7 packages. So we'll need 7 packages to put all the cupcakes in. Okay, problem number 6. It says which number is odd? So we're looking for the number that's odd. And basically what that means is if I was to divide each one of these into 2 equal groups, I wouldn't have the same amount in each group. So I'm looking for the number that's odd. And that would take quite a while. I could do that on all this. We'll do answer choice H really quick. I'll put H into 2 equal groups. So I'm going to make my groups here. That's 1 group and that's 2 groups. I'm going to start putting 168 in. I'm not going to do by ones. I'm going to count by tens because that would take too long. So I'm going to start putting them in. That's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160. Now I'm going to go by ones. 61, 62, 63, 64, 65, 66, 67, and 68, 168. So you can see when I divided those 2 numbers, had an equal amount in each group. It looks like I have 84 in that group and 84 in that group. So that number would be an even number. It would not be odd. So if it's not even, it automatically becomes an odd number. So that is an even number, so that would not be my odd number. But there's a quicker way of doing it. Okay, we can just look at the ones place. No matter how large the value the number is, and no matter what the other digits are, the ones place is really going to tell us whether the number is even or odd. So all my odd numbers, if I have these numbers in the ones place, that means the entire number is odd. So if I have a 1, a 3, a 5, a 7, or a 9 in the ones place, that would make that an odd number. So we're looking at answer choice F. It does have a 5, so I think that may be my odd number. We'll look at the rest of them though. Okay, this one has a 0 in the ones place, and that would not be an odd number. Where I said that the answer choice A, 268, is an even number, but we'll look again. There is not one of those numbers there. And for 514, the 4, I don't see a 1, 3, 5, 7, or 9 there, so that would make that an even number also. So our number that's odd is F, 205.
Unpause it. We will look at our answers together. So Freddie's got some money in his account. He's going to start with $256, and he's going to put $50 more, and then he's going to take out $87. And if you notice, all of our answer selections here include those three numbers, 256, 50, and 87. So we're needing to write an equation that can be used to find the amount of money he had after this right here. So this is where he took his money out. So we want to basically figure out, after he's done all this, how much money does he have left? But the question is, are we going to add twice, or we're going to subtract twice, add once, or subtract? Add once, subtract once, and in what order? Those are the four options that we have. So typically we can draw a picture, make a representation. So let me draw something that some of you might not use a whole lot. I'm just going to draw a number line. Now I'm not going to try to draw little hash marks for every single number. That's not going to work. But let's say he started with 0, and then for our purposes, he's going to start, let's just put 256 right here. So most big accounts start with 0, but in this story, he is going to start with $256. Now, he's going to put $50 more into his account. So this doesn't say add or subtract. This is what you as a third grader have to figure out, that when you're putting more into something, it means you're adding something. And so that's a real world application of trying to figure out, when do I add, when do I subtract? So we're going to add 50. So I'm going to draw just another little line like this. I'm going to put a plus 50. Now, I don't know what my new number is until let's just go ahead and add that, 256 plus 50. So he's got, oh, look at that, $306. Good for him. But now he wants to buy a bike, which is a great use of that money, and he's going to take out $87. So we have two clues in this sentence as to whether we add or subtract. So when you take something out, you're subtracting. And also when you're buying something, you're subtracting, because you have to give money to the store in order to take the bike out. And so we're going to subtract 87. So what I can do is, since we ended at this 307, I'm going to just draw another arrow up on top. And it's going to, I don't know how much farther back it's going to go, but I'm going to make it go back farther than the 50, because I know 87 is larger than 50. So I'm just going to do it 87 minus 87. And that's how we could represent this story problem with a number line. It doesn't help us with the equations quite yet, but it will in just a moment. So let me first figure out how much money he ended up with. 306 minus 87. Oh, we're going to have to regroup across the zeros. Go all the way over to the hundreds place. Make that tens place a 10. So now we've got a 9. Now we can do my 16 here. So we've got 9, There we go. He's got $219. And if I wanted to, I could just write this 219 in each of these and then work out the problem. And I could work out each of these problems by adding twice, subtracting twice, whatnot. But we've basically already figured out what we needed to do. We start with 256, which each of these does. The first thing we did was we added 50. So that was our first step. So that means we're not going to use C because that subtracts first, and we're not going to use A because that also subtracts first. And then we finish by taking away the 87, and so that is going to leave us with this D, because if you look at B, you're wanting to add both the 50 and the 87, and that is going to be much too large. So our answer is D, 256 plus 50 minus 87. We did that by drawing this extended number line. We could also have just drawn a picture, or like I said, if you are just really stuck and you think you know the answer, just go ahead and do the math. Figure out what all of these equals, and only one of them, D, is going to equal 219. That's our answer.
Okay, question number 8. Follow along as I read. It says Brandon drew the two congruent squares shown. So these two squares are congruent, the same size, same shape. He divided one square into two congruent triangular parts. He divided the other square into two congruent rectangular parts. Which statement is true? So let me go ahead and do that first. I'm going to draw a line diagonal across here, and that should make two congruent triangles right there. This triangle, that triangle, are same size, same shape. And if I go ahead and just split this one in half long ways, that should make two congruent rectangles. So we're going to go through here and answer these questions, put true and false statements beside them. And we should end up with one true statement and 3 false statements. So answer choice F, it says, each triangular part and each rectangular part represent 1/2 the area of one square. That sounds like a true statement to me. Okay, because we said that the squares are congruent, and right here, the triangular parts are congruent and the rectangular parts are congruent. So that means that they both represent the same amount, represent 1/2 of the square. So look at answer choice G. Each triangular part has an area that is greater than the area of each rectangular part. That is false. They are the same. Congruent squares and congruent shapes. Answer choice H. Each triangular part and each rectangular part represent 1/4 the area of one square. And how you could probably get confused with that is if you kind of sat here and looked at this, you said that's one part out of 1, 2, 3, 4 parts. That would sound right. That would sound like 1/4, but it's talking about one square. It's talking about one square or one whole shape right there. So that would be a false statement. And answer choice J says each rectangular part has an area that is greater than the area of each triangular part. And that is false. We already said they are both the same area. So the correct answer would be answer choice F.
So Felix is doing quite a bit here. He's spending 19 minutes on his swimming, 21 minutes on his riding his bike, and 30 minutes on running. So we need to find the total amount. So that's going to be add. Seems like it's a pretty straightforward problem so far. Total amount of time that he spent swimming, riding his bike, and running the race. All right, so we need all 3 of these times. There's no extra information here. So can we just add it up? Well, let's see. Let's see what happens if we just add these numbers up, because we're adding minutes. And sometimes adding time is a little bit weird, but since we're just adding minutes, minutes is just another unit. So you could be adding minutes, you could be adding meters, you can be adding quarts, gallons. It doesn't really matter. If you're just straight adding a unit like this, you can add like normal. It's when you try to add time with minutes and hours, that's when it gets a little bit weird. But let's see what we have here. 9 and 1, that's going to be 10. So 1 and 1 is 2, add another 2 is going to be 4, and then 3 is 7, so 70 minutes. And that's where the trick comes in, I guess, because that is not one of my options. So we have this analog clock here. Let's see if we can use it to try to make sense of all of this. So 70 minutes. So what I'm going to do is we're going to keep this. The 70 minutes is good. We know it's 70 minutes. And for the most part, we can probably say it's not going to be 40 minutes because it's more than that. But let's say I don't know how to turn minutes into hours in minutes. How can we use an analog clock to do that? Well, let's just take the minute hand here. It doesn't even really matter what the hour is. There is no actual time that we know that he started all of this stuff in a race, so we're just going to use the hour here. And this is at the o'clock, right? So what I'm going to do is I'm going to skip count by fives. You know that each of these are fives. We got 5, 10, 15, 20, all the way around. I'm going to skip count by fives, and then we will see what we have left. So we'll just keep going. 30, 35, 40, 45, 50. If you don't want to write all of them out, just think your fives facts. So if I'm going to start at o'clock and I want to go to 70 minutes, let's see what I have here. So I've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. I'm going to stop right there. 60 minutes. It says the o'clock, but I also remember that 60 minutes, that's the same as 1 hour. So if I do 60 minutes, my minute hand, remember there is no hour hand here, I'm just looking at my minutes. My minute hand goes all the way around. So I can say 60 minutes is at the 12 o'clock, just like the o'clock. And every time you hit that 60 minutes, you get another hour. Well, all I need to do is to get from 60 up to 70. So let's start back where I stopped. 60, 65, 70. So I would be right there at the 2. What is that 2? Well, remember that this 2 is at the 10-minute mark. It's right there, but we just kind of wrote all over it. So it looks like if I took my 70 and I split it up, and this makes sense now, we could do it like this. 60 plus 10 is the same as 70. So this is the same as this. It's kind of like a fraction, right? Finding an equivalent fraction. We didn't make it say anything different, we just made it look different. So now we can bring this 10 minutes over, and look what I have. I've got 1 hour and 10 minutes. So that's going to be my answer C. And this D is just too small. That would be 60 minutes. And this A is too big. That would actually be 80 minutes. And that is going to be 70 minutes C.
Okay, question number 10. It says there are 8 oranges in each bag for sale at the store. Which table shows the relationship between the number of bags and the number of oranges in the bags? So it's important. There are 8 oranges in each bag. And so we're looking for the relationship between the number of bags and the number of oranges in the bags. So for every bag, there's going to be 8 oranges. Sounds like equal size groups. So the relationship would be number of bags, we'll put number of B, times 8 will equal the number of oranges. So the relationship on our table would be times 8. So if we look at so we'll go ahead and look at the answer choices here and see which one matches that. So on the first one, there's just 2 bags, so that'd be times 8. And that doesn't work. 2 times 8 is not 8. So we can eliminate answer choice F. That would be, there would be 8 oranges in 1 bag. So that doesn't work. Look at answer choice G. So we got 2 times 8. That does equal 16. That works. 3 times 8. That equals 24. That works. We got to check out them all. It's got to work on all of them, though. 4 times 8. That equals 32. And 5 times 8 equals 40. So this looks like it may be our answer. We're going to go ahead and check the rest of them. On answer choice H, 2 times 8, does not equal 10. Looks like the relationship on this one is +8. So 3 plus 8, yeah, 4 plus 8, and 5 plus 8. So we're not using answer choice H. That would not be the correct. And then the last one, J. 2 times 8 equals 16. That works. Then we have to check all the data though. 3 times 8 does not equal 32. And 4 times 8 does not equal 64. And 5 times 8 does not equal 128. Looks like right here they're doubling every time. Looks like they're times 2 going down. If you double 16, you get 32. 32 times 2, 64. 64 times 2. So it's not answer choice J. Our correct answer would be answer choice G. Okay, question number 11. It says, which figure cannot be classified as a prism? So we're looking at the one that is not a prism. Cannot be classified as a prism. And we have 4 3D shapes here. Okay, and 2 of them I do recognize as prisms automatically. This is a triangular prism. So this is a prism. I'll put a T right there. That's a triangular prism. And this D is a rectangular prism. So that can be classified as a prism. I have 2 other shapes here. I have right here, it looks like a cube and a cylinder. So I know in a cube has all the same attributes as a rectangular prism, and we can classify a cube as a rectangular prism because a rectangular prism has 2 rectangular bases with rectangular faces connecting those bases, and a cube has 2 rectangular bases with rectangular faces connecting them. So A is a prism too, can be classified as a prism, but C is not a prism. C is a cylinder, and cylinders are not circular prisms. It cannot be classified as a prism because it doesn't have rectangular faces connecting the bases, and the bases have to be polygons to be a prism. So C is the one that cannot be classified as a prism.
All right, so we have looks like a fairly simple problem, but it might be a little bit more difficult than we think. We've got Stacy. She's using 21 feet of ribbon, and she used 3 feet for each bow. Which equation can be used to find the number of bows that Stacy made with this ribbon? So we need to find the number of bows. And so you notice all of our answer selections, F, G, H, and J, they're all going to use 21 and 3, the only 2 numbers we have in the problem, and they're simply going to use a different operation, multiplication, division, addition, or subtraction. So we're not going to be able to find our answer there. What we are going to need to do is probably draw a picture, maybe a strip diagram. So let's see if we can draw a little bit of both. And so I'm going to start with this. I'm going to start with this 21 feet. Because it says she used 21 feet of ribbon to make bows, and to me, this looks like my total. And so whenever we get our total, whether it be addition, subtraction, multiplication, division, we're going to put it up on top of the big box there. And then she used 3 feet of ribbon for each bow, and we need to know how many bows we can make. So it looks like what we're going to do is we're going to take sets of 3, and then we're just going to try to figure out, well, how many bows can she make? How many sets of 3 can she get out of there? So what we could do is we can do this. We can just set up 21 feet. I'm just going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we'll do my 21st one down there. I'm not going to cross it off because I want each one to be separate. These are going to represent my 21 feet. And it says here that we're going to use 3 feet for each ribbon. So what I'm going to do is I'm just going to circle sets of 3. So I'm going to do, well, that's 1, 2, 3. I'm going to circle that one. That's going to be kind of weird down there. I've got one right here. Let's see, I can kind of make a set of 3 right here, and then I can make a set of 3 right there. So how many sets of 3 did I make? 1, 2, 3, 4, 5, 6, 7. So I made 7 groups of 3, and that made 21 feet, and that makes sense. And so if I were to use that as a strip diagram, could I do that? Could I do 7 down here? Could I set up 3, 6, 9, 12, 15, 18, 21. So yes, that works. But take a look right here. 7 times 3. So we know that she made 7 bows. But 7 times 3 equals 21 is not one of my options. I do have a multiplication, but it looks like 21 times 3, and that's going to give me 63. Well, let's go back to my original strip diagram. This is actually a strip diagram that shows division. Whenever you see this right here, you can see multiplication. You can even see addition if you really want to, because multiplication is repeated addition. But this strip diagram right up here is actually division, because you've got 21 and you've got sets of 3, and this question mark means you don't know how many sets you have. And keyword for that is going to be each. So what we could do here is we can say, well, we've got 21 divided into sets of 3, and now that we know we are going to make 7 sets of 3, that's going to give us our answer here as G. We're not going to multiply because we're not going to make 63. Then addition and subtraction don't work because this each lets us know it's going to be multiplication or division.
Question number 13. It says fraction strips are shown, so it's a fraction strip. It says which comparison and explanation is true? So it looks like we're comparing 5/6 and 5/8. So just to make it a little bit easier, we'll go ahead and shade in our fraction strips to represent our problem. So I'll shade in 5/6 first. These are my 6 because I've broken down into 6 equal parts. That's 3, 4, that's all but 1 is 6. That's 5/6. And 5/8, that's 4, 5, just a little bit more than a half. So I'll shade that all in there. Pretty good right there. Okay, so this is my 5/6, and this is 5/8. And it's easy to see when you look at them that 5/6 is larger than 5/8. It goes further there. It's only 1/6 away from being a whole, where this is 3/8 away from being a whole. And you can see it's not as far. These are both the same length strips right here. And this one's broken into 8s, and this is broken into 6. Another thing we know is the more times we break things apart, the smaller they're going to get. So 6 are larger than 8s. First thing I do is go ahead and eliminate any of the answer choices saying 5/8 is larger than 5/6. So right here, this is not a true statement, and this is not a true statement. But I have C and D down here that's saying that 5/6 is larger than 5/8. That's true. 5/6 is larger than 5/8. So now we'll go ahead and look at the explanation. Right here it says because 8s are larger than 6. We look up here, we see that 8s are actually smaller than 6. So that is not true. This part is not true right here. And we'll look at the last one. It says because 6s are larger than 8s. And that does sound like a true statement. Another way we can do when we're comparing fractions is whenever they have the same numerator, the one with the smallest denominator is going to be larger. And in this case, the 6th is the smaller denominator because we broke it into less pieces. So the correct answer would be answer choice D. 5/6 is greater than 5/8 because 6 are larger than 8s.
So we have this square, looks like it's a journal cover, and we are simply looking for the perimeter. Now you notice that we only have one measurement, and there are no multiple choice answers to choose from. There's no A, B, C, or D. We just have to figure this out on our own. So first, let's make sure we figure out what perimeter is asking us for. Because if we don't know what that is, we're going to have a hard time. There's no answers for us to choose from. So the perimeter is the outside. So we're always looking at the outside around an object. If we ever are asked to find the area, that's the inside. So that's where we put the squares inside and see how many squares it takes. But we're dealing with the outside of this square journal cover. And so we need to find the perimeter. And so how we find the perimeter is really, it's for a square, it's the side plus the side plus the side. And then there's always a fourth side plus the side. And so if we wanted to do that, we could take 24 here and we could just add it 4 different times. So let's go ahead and do that. So we've got 24. Since it's a square, we know that squares have each side as the exact same length. So that's why they're not going to give you, or they're not going to write for you, this 24 all the way around. Since they said it was a square, you were supposed to figure out that squares have equal sides. And if you see a 24 centimeters on one side, it is reasonable to say that each side is going to be 24 centimeters. So let's just do some repeated addition here. So let's just do 24, 24, 24, 24. And let's see what we get. 4, 8, 12, that's going to be 16. And let's see, 2, 4, 6, 8 at that 1 is going to be 9. So it looks like our answer is going to be 96 centimeters. Now, you probably recognize that I did repeated addition. And if you're looking on your formula chart, you're not going to get side plus side plus side plus side. You're going to get perimeter. And then let's just put a little square down here because the perimeter is slightly different formula when we're looking for perimeter of a rectangle or the perimeter of a square. But you're going to get something that looks like this, 4s. And that might look a little bit strange. Now, this is what happens when you get a number next to a letter. So this S, that stands for side. And so we have the side length of 24 right here. But whenever you have a number and a letter next to each other, it always means multiplication. And this is something you're going to see in 4th grade, 5th grade, 6th grade, all the way for the rest of your mathematical life. You're going to see numbers next to letters, and there's not going to be any operation. When there's no operation like addition or subtraction or division, it's always going to be multiplication. So really what we're looking at is 4 times the side length. And the side length here is 24. So we're just going to replace this 24, put that where that S is. And so we know how to do 2 by 1 multiplication, 24 times 4. And so that's going to be 4 times 4 is 16. Carry that. 4 times this 2, going to be 8 at that 1. So we've got that 96. Either way you look at it, whether it's repeated addition or whether it's multiplication, it does look like the answer is going to be 96. Now, how are we going to fill that in? So you are going to have a bubble chart like this, and it's going to have a few columns. Now, this first column is just going to have a decimal. That's it. And then you're going to get some columns that look like this. And you've got the ones, you've got the tens, and you've got the hundreds. So what you need to do is you need to make sure that you put your 96, you put your 9 in your 10 spot, you put your 6 in your 1 spot. So you're going to find the 9 down here, and you're going to bubble it in. You're going to find the 6 over here. You're going to bubble it in. And in the 100 spot, leave it blank. You're not going to put a 0. You're not going to bubble anything in. And if you do it like that, you will get the correct answer, 96.